Okay, so for the last part of this lesson, I just want to look at comparing the three tests that we've talked about in the last couple days. So one of the hardest parts about this chapter is actually going to be knowing the difference between these three tests. I know the work between these is pretty much the same, but it is important to know what test you're calling it based off of the information. So tomorrow you will get some examples where you have to read through the example to determine which is the best fitting test. So let's go over the differences between these. The first one we talked about, the chi-square goodness of fit, that looks at one variable in one population. The example we did was the Skittles example, the very first day. What we did on that example is we looked at the one variable, which was color. I know there was red, orange, yellow, green, purple, whatever. But we looked at the one variable color in one population, all Skittles. And we were comparing the sample that we took to the claim that they gave us, okay? The next test I taught you was the chi-squared test of homogeneity. And what we did there is we looked at, again, one variable, but this time we would do it in two or more populations. Okay, we only did two in the example. The example we did was Facebook habits from RHS or Redwood versus Matt Whitney. Oops, I'm doing this all wrong. Sorry. Redwood versus Matt Whitney. Now, we only did two populations, but I could have, if I wanted to, interviewed people at Golden West and at El Diamante and had four populations and looked at the Facebook habits between all of those. The key here, though, was I was only interested in looking at one thing, Facebook habits, but I'm comparing that one variable between two or more populations. Now, the chi-squared test of independence, what the first video we looked at two variables in just one population. We only took one sample, but we looked at two pieces of information within that one sample. So the example that we did just a little bit ago was math class versus sport played. Okay, we took one sample. We asked one sample of high school students, but we collected two pieces of information, math class and sport played, and we compared the two. Okay, so that's kind of the difference between these, and you will need to practice knowing the difference between all of those tests. Now, something I wanted to show you is we can do another type of test that gives you basically the same information as any of these chi-squared tests. So let me show you an example. Some people look a lot like their pets. Maybe they deliberately choose animals that match their appearance, or maybe we are perceiving similarities that aren't really there. Researchers at the University of California collected the following data from a random sample of 45 dogs and their owners. Well, I sure hope I don't look like my dog. But anyways, we want to take a look at this. So here's our two-way table. It says down here, do we have strong evidence to suggest that dogs look like their owners? Use your calculator to find the test statistic and the p-value. Well, in order to do this, we do need to know what type of test are we going to be using. So what type of test do you think we're going to use? Hopefully you've narrowed it down to at least a chi-squared test of homogeneity or independence. The giveaway there is that they gave you a two-way table. So it is one of those two, but notice here we're looking at a random sample and we asked two pieces of information. We asked what type of dog do you have, and then we recorded whether or not they looked like their owner. So there's two pieces of information we're gathering from one sample, which makes this a chi-squared test of independence. Okay, and again, it's because we took one sample and recorded two variables. Okay, so instead of going through the full four-step process, we're going to go ahead and just use our calculator. So go ahead and pause my video and run the steps through the calculator like we did on the last video. Okay, hopefully you got a chance to do that. I'll quick show you what you should have done. Sorry for the darker video. It is evening actually right now, and so it's darker lights in here. But here is my calculator. What I'm going to do is hit my matrix. I got to put in my matrix. Okay, I no longer have a 3x4, so I need to edit that. I'm going to change this to a 2x2. And then I'm just going to type it in. 16 that resemble their owner, 9 that don't within the purebreds, 7 that resemble their owner, 13 that don't within the mixed breeds. Now that it's all stored in there, we can go ahead and go back to Stat, scroll back over to Tests, and find the chi-squared test. All you have to do is scroll down and hit Calculate, since all of our observed are already in matrix A. So there's our chi-squared and our p-value, which is what the notes are asking us for. So going back to the notes, the test statistic is chi-squared equals 3.73962. There's a reason why I'm going out that many decimals. And the p-value is 0.05313. Okay? Now, is there another type of test that we could have done instead that would have given us the same results? Well, think about it. We're dealing with proportions here. That's what all of these chi-squared tests are, is dealing with proportions. So let's look back up at our 2A table. In fact, why don't we look at the proportion of purebred owners who look like, or purebred dogs who look like their owner? If I were to create that proportion, I would say there are 16 dogs that look like their owner out of 25 purebred dogs, and I added the 16 and the 9 to get 25. Let's go ahead and call that p hat 1. And out of the mixed breed dogs, there are 7 out of a total of 20. 7 plus 13 is 20. Let's go ahead and call that p hat 2. So what we could do is take these two proportions and compare those. So what type of test does that? Well, a chi-squared test. I'm sorry, not a chi-squared test. It is a chi-squared test, but I could say a 2 proportion z-test. But it does need to be two-sided. We don't know which one is greater than the other, so we're going to go ahead and do a two-sided test, which is when our alternative is the not equal. So again, go ahead and pause my video, see if you guys remember how to do that. Okay, in case you forgot, again, I'm hoping that you're trying this on your own first. I'm going to go back to my calculator and I'm going to run another test. So I'm going to hit Stat, scroll over to Test, but this time I'm going to do the 2 proportion z test, like I just mentioned. So what I have here is I have 16 that resemble their owner out of 25 total. And then I have 7 mixed breed dogs that resemble their owner out of a total of 20. Okay, so I've got my 2 proportions plugged in there. Again, it's a two-sided test, so I'm going to use the not equals to, and I'm going to hit Calculate. So you can see they give you the z-score, they give you the p-value, and so let's go ahead and write those down and take a look at what we have. So the test statistic is a z in this case, because it's a 2 proportion z-test. The p-value is 0.05313. Wait a second, did you guys notice that that's exactly the same? That's pretty cool. And I forgot to write the z. The z is 1.93381. Well, the p-value ends up being exactly the same. That's because this test will give us the same information as a chi-squared test of independence. But is there any kind of relationship between chi-squared and z? Well, this is a squared to it. This is just z. So I wonder if I took a z and I squared it, would that be equal to the chi-squared? Well, let's try. Let's take the 1.93381 and let's square it. Well, what do we get? 3.73962. They are equal. So there is a relationship between the chi-squared test statistic and the z-score test statistic. So notice that the p-values are indeed the same, and that for the test statistics, If I take z and I square it, it does in fact equal chi-squared. Now, this actually only works for two-sided two-proportion z-tests. So you may want to make a note of that. Okay. But that is a relationship amongst some of the tests that we've already done. So if you actually prefer some of the two-proportion z-tests, as long as it's two-sided, you could do this instead of a chi-squared test. This would work for an independence test or a homogeneity test. So just an interesting thought that I wanted to show you guys, linking some of the stuff that we've done together. So that is the end of this lesson. I hope you've done okay this chapter watching these video lessons. I know it's hard because I'm not there, but please make sure you guys are reading the book. That's going to be one of the best things you can do to gain more information. And again, feel free to text me through Remind if you guys have questions. So good luck studying for the test, and I hope you're doing well.